We learned about variables in statistics. If you have a discrete random variable, you can find the probability of each variable, which is denoted by P of X. Especially for a discrete random variable, we can form frequency table, and the relative frequency for each X is the probability of that X. Let's take a look at this example. This example says the table below lists the number of computers per household in the United States. So these are the information that we have. They already written this information in compact and nice format. So it was basically like this. You had a collection of people completing the survey. 27 households says we don't have any computers. 0 means we don't have any computers. Some of this says we have only 1 computer at home. Some other says we have 2 computers at home. Some other says we have 3 computers at home. Some says 4, some says 5, and so on. They got this information and written nicely in this frequency table for us. Now we want to know what is the probability. Probability that we randomly select a household and that household has no computer. This is the English representation. Mathematically, you say that, hey, what is the probability that X is 0? And as you can see, these are countable values. We can easily count them. No computer, 27. 1 computer, 47, and so on. So you have the frequency or count for each variable. What is the probability that you randomly select a household with no computer? Remember that it is equal to the relative frequency. So how many households were there in total? To find the number of households participating here, we need to add all of these numbers together. After adding them, we see we have 114 households, or we have 114 responses. The probability that X is 0 is the size frequency, which is 27, divided by the total number of people or responses or outcomes, which is 114. This is 0.237 or 23.7%. So P of X, the probability of X being 0 is 23.7%. And continue this process. But if I randomly select a household with only 1 computer, 1 computer counts is 47. So 47 divided by 114, which is 0.412 or 41.2%. So the probability that X is 1, you have 41.2%. What is the probability that X is 2? Well, if you randomly select a household and they have 2 computers at home, 24 households have 2 computers, so 24 divided by 114, which is equal to 0.211 or 21.1%. 21.1%. But if I randomly select a household and that household has 3 computers at home, 10 divided by 114, which is 0.088, which is, let's see, here we have 8.8%. So 8.8% of households in the United States have 3 computers at home. But if I want to find the probability that X is 4, the probability that X is 4 is equal to, well, that happens, these two numbers are the same. 4 households have 4 computers at home, divided by 114, which is 0.035, or 3.5%. 3.5%. And finally, what is the probability that you have 5 computers at home? Only 2 households have 5 computers at home, which is, let's go up a little bit, 0.018, only 1.8%. 1.8% of all households in the United States have 5 computers at home. So we basically formed the frequency table. This is relative frequency, which now we call it the probability for random variable, discrete random variable X.